Alright, this video is on how to determine the equation of the quadratic function given the zeros, which are the x-intercepts, and another point. Okay, so the zeros are the x values that make y 0, or the x-intercepts. Okay, so in factored form, we see that the zeros are s and t. So if you're given the zeros, the x-intercepts, then you can just plug them into this form. And same as the last one for vertex form and a point, the vertex and a point. Well, we've got the x-intercepts and a point. Plug them into this form. Plug the point in for x and y, and then you can solve for a. Okay, so this is basically what this says here. If you s and t are the zeros, if you're given the zeros, then you can just sub them into and all that is left to find is a. You have another point, you sub it in for x and y and solve for a. So here's an example of this. Okay, so the zeros are x equal to -3 and 1. You never put brackets around that because otherwise it looks like a point. Okay, and the point is -2, -6. Okay, so this is just an example. So sub these -3 and 1 in for s and t in here. Okay, so you do that, and you get y equals a x plus 3. Okay, so it's x minus s, so minus -3 means plus 3, and then x minus 1, right there. That's s and t. Now you can sub in the point. Okay, you sub in the point, so y is -6. X is -2, so wherever there's an x, you put in a -2. You got to put it in twice here. Okay, and then you evaluate this side. So -6 stays the same on that side. -2 plus 3 is 1. -1 minus 1 is -3. You multiply those two together, you get -3. Okay, so -6 equals -3a. Divide both sides by -3. And you get a equal to 2. So a equals 2, you can sub it in here. So a equals 2. Sub it in here for a. You get 2, x plus 3, x minus 1. And that's the equation of the quadratic in factored form. Okay, a couple more examples. So let's take a look at here. Just zoom in a little bit more. Okay, and got one here where the x-intercepts are -1 and 3, and the point is -2. So there's s and t. Plugging them in, you get y equals a times x plus 1 and x minus 3. Sub in the point 2, -2. You've got this. Okay. Now you can evaluate that. -2 equals -3a. Divide both sides by -3, and you get a equal to 2/3. And plug that in for a in the factored form. So -2/3 x plus 1, x minus 3 is the equation of that parabola, that quadratic. Okay. Another example here. So the x-intercepts are -2 and 4, and the point is 2 and 5. So sub in the x-intercepts first. So x plus 2 and x minus 4. Sub in the point. You can do that all in one shot if you wanted to. Okay, so 2 is in for x in those two places, and then 5 is in for y. Evaluate, simplify, and you get a equal to -5/8. And now you can plug that back in for a here, and you get y equals -5/8 times x plus 2 times x minus 4. A couple more examples and then we're done. So let's take a look at this one. Well, here's a special case. So the x-intercept is 3, and the point is 0, -2. There's only one x-intercept. So what do we have in this case? When you have one x-intercept, then you actually have a perfect square. Okay, so you have something that looks like this. It's going to be y equals a times x minus 3 times x minus 3, which is just x minus 3 squared. Okay, now you can sub in the point 0, negative 2. So 0 in for x, negative 2 in for y. You get negative 2 equals 9a. Evaluate that. A equals negative 2 over 9. Sub that into the form. You get negative y equals negative 2 over 9 times x minus 3 all squared. And the last example is this one. Well, when we get same numbers opposite sign for the x-intercepts, we have a difference of squares. And so the point that it goes through for this one is 2, negative 2. So let's see what happens. So y equals a times x plus 3 times x minus 3. Okay, plugging them in. Sub in 2, negative 2. Okay. So 2 for x and negative 2 for y. And simplify that side. Okay, negative 2 equals negative 5a. A equals 2/5. And then y equals 2/5 x plus 3 times x minus 3. And that's it for finding the equation of a parabola given the x-intercepts, the zeros, and a point.